Have you ever wondered why birds can fly while we humans can't? It's a question that has sparked curiosity and fascination throughout human history, leading us to ponder, innovate, and ultimately take to the skies ourselves. The miracle of flight, a spectacle we see every day, is a marvel of the natural world that has inspired countless inventions. From the simple kite flown by a child in a park, to the roar of a jumbo jet soaring thousands of feet above the ground, flight is a testament to our ingenuity and tenacity. Yet it all started with the birds. Their effortless soaring and nimble aerobatics have captivated us, making us yearn to emulate their freedom of movement. But what's the secret behind a bird's flight? It's not as complicated as you might think. You see, the key to a bird's flight lies in its anatomy. Let's start with the bones. Birds have a unique skeletal structure, where their bones are lightweight yet strong. This is due to a phenomenon called pneumaticity, where many of their bones are hollow and filled with air sacs. This makes their bodies lighter and thus easier to lift off the ground. Next up, we have the feathers. Not just a fashion statement, feathers play a crucial role in flight. The large feathers on a bird's wings and tail, known as flight feathers, are essential for creating lift and steering. The smaller feathers, known as contour feathers, provide insulation and streamline the bird's body for efficient travel through the air. Then there's the bird's wing shape. Different birds have different wing shapes, each designed for a specific type of flight. For example, birds like eagles and vultures, with long, broad wings, are built for soaring and gliding. On the other hand, birds like sparrows and finches, with short, rounded wings, are designed for quick, agile flight. But it doesn't stop there. Birds also have a specialized respiratory system that allows for efficient oxygen supply during the high-energy activity of flight. Unlike us, birds have a one-way airflow system in their lungs, meaning the air moves through in a single direction, allowing for continuous oxygen supply, even when the bird exhales. Lastly, let's talk about the bird's heart. It's no secret that flight requires a lot of energy, and to meet this demand, birds have large, powerful hearts. This allows for a high metabolic rate, ensuring that the bird's muscles get the oxygen and nutrients they need during flight. In summary, a bird's anatomy, from its lightweight bones and specialized feathers to its efficient respiratory system and powerful heart, all play a part in its ability to fly. With these features, birds are well equipped for flight, but how do they actually take off? Birds, like airplanes, follow the laws of physics to take to the skies. So, let's dissect this fascinating phenomenon, shall we? There are 4 fundamental forces at play: lift, drag, thrust, and gravity. Lift is the force that directly opposes the weight of the bird and lifts it into the air. As a bird moves forward, the shape of its wings creates a difference in air pressure. The air above the wing moves faster than the air below, causing lower pressure on top, and voila, lift is created. This principle is known as Bernoulli's principle. Next up, we have drag. This is the air resistance that a bird faces when it moves through the air. It's like trying to run underwater. The water pushes against you, slowing you down. For birds, the sleek design of their feathers helps to minimize this resistance, allowing them to glide through the air with grace and ease. Then we have thrust, which propels the bird forward. Birds generate thrust by flapping their wings. As they push down on the air pushes back, propelling them forward. This is Newton's third law of motion in action. For every action, there's an equal and opposite reaction. Last but not least, we have gravity, the force that keeps us all grounded quite literally. For birds, gravity is a constant downward pull they must overcome to stay airborne. This means they must generate enough lift to counteract their weight. If a bird stops flapping or gliding, gravity will inevitably bring it back down to earth. So when a bird takes flight, it's a delicate dance between these 4 forces. They must generate enough lift to overcome gravity, enough thrust to overcome drag, and maintain this balance to stay in the air. It's a complex process, but for birds, it's as natural as breathing. Now that we know how birds fly, is there more to it than just physics and anatomy? Do birds have a secret ingredient that makes them the masters of the sky? Well, stay tuned to find out. Indeed, there is. Like any other living creature, birds need energy to fly. This energy, crucial to their ability to soar through the skies, is derived from the food they consume. The process is fascinating. When a bird eats, its body breaks down the food in a complex process called metabolism. This process releases stored energy in the food, which is then used to power the bird's muscles for flight. Birds, however, are not just any creatures. they are remarkably efficient in their energy usage. While we humans might feel exhausted after a short jog, birds can travel vast distances without tiring. This is because their bodies are designed to make the most out of every morsel of energy. Their heart rates, respiratory systems, and muscle structures all work in harmony to ensure that not a single bit of energy goes to waste. So now we know why birds can fly. It's a combination of their anatomy, the laws of physics, and energy usage. In conclusion, the ability of birds to fly is a fascinating combination of biology and physics. We've journeyed through the miracle of flight, marveling at the beauty of the avian world. We've explored the intricate anatomy of birds, understanding how each feather, each muscle, and each bone plays a vital role in their ability to soar through the skies. We've delved into the physics of flight, the dance of forces that allows these creatures to conquer gravity. We've seen how lift and thrust work together, with air pressure and air resistance playing their parts in this mesmerizing ballet of the skies. We've also touched upon the role of energy, how the metabolic energy of birds fuels their flight, and how they masterfully manage this energy for long-distance travels. This understanding of bird flight has not just satiated our curiosity, but has also had a profound impact on human invention and innovation. The principles of flight have been instrumental in the creation of our own flying machines. From the Wright brothers' first airplane to today's advanced drones and future Mars rovers, the study of bird flight continues to inspire and guide our innovation. Understanding these concepts helps us appreciate the complexity of nature and the wonders it holds. It reminds us that every creature, every phenomenon, is a marvel of evolution and physics, waiting to be understood and appreciated. So as we wrap up this journey, let's carry forward this curiosity and thirst for knowledge. Let's continue to marvel at the world around us, to question, to explore, and to learn. Thank you for joining us on this journey through the sky. If you enjoyed the video, please don't forget to subscribe, like, and share. Stay curious and keep exploring.